File allocation table is a computer file system architecture and a family of industry standard file systems utilizing it. The FAT file system is a legacy file system which is simple and robust. It offers good performance even in lightweight implementations, but cannot deliver the same performance, reliability and scalability as some modern file systems. It is, however, supported for compatibility reasons by nearly all currently developed operating systems for personal computers and many mobile devices and embedded systems, and thus is a well-suited format for data exchange between computers and devices of almost any type and age from 1981 up to the present. Originally designed in 1977 for use on floppy disks, FAT was soon adapted and used almost universally on hard disks throughout the DOS and Windows 9X eras for 2 decades. As disk drives evolved, the capabilities of the file system have been extended accordingly, resulting in 3 major file system variants: FAT12, FAT16 and FAT32. The FAT standard has also been expanded in other ways while generally preserving backward compatibility with existing software. With the introduction of more powerful computers and operating systems, as well as the development of more complex file systems for them, FAT is no longer the default file system for usage on Microsoft Windows computers. Today, FAT file systems are still commonly found on floppy disks, USB sticks, flash and other solid-state memory cards and modules, and many portable and embedded devices. DCF implements FAT as the standard file system for digital cameras. FAT is also utilized in the boot stage of EFI-compliant computers. Overview. Concepts. The name of the file system originates from the file system's prominent usage of an index table, the file allocation table, statically allocated at the time of formatting. The table contains entries for each cluster, a contiguous area of disk storage. Each entry contains either the number of the next cluster in the file, or else a marker indicating end of file, unused disk space, or special reserved areas of the disk. The root directory of the disk contains the number of the first cluster of each file in that directory. The operating system can then traverse the FAT table, looking up the cluster number of each successive part of the disk file as a cluster chain until the end of the file is reached. In much the same way, subdirectories are implemented as special files containing the directory entries of their respective files. Originally designed as an 8-bit file system, the maximum number of clusters has been significantly increased as disk drives have evolved, and so the number of bits used to identify each cluster has grown. The successive major variants of the FAT format are named after the number of table element bits: 12, 16, and 32. Except for the original 8-bit FAT precursor, each of these variants are still in use. The FAT standard has also been expanded in other ways while generally preserving backward compatibility with existing software. The FAT file system has a long history of usage on desktops and portable computers, and it is frequently used in embedded solutions. FAT offers reasonably good performance and robustness, even in very lightweight implementations. It is therefore widely adopted and supported by virtually all existing operating systems for personal computers as well as some home computers and a multitude of embedded systems. As such, it continues to be the most widespread file system worldwide. This also makes it a useful format for solid-state memory cards and a convenient way to share data between operating systems. FAT file systems are the default file system for removable media and as such are commonly found on floppy disks, super floppies, memory and flash memory cards or USB flash drives, and are supported by most portable devices such as PDAs, digital cameras, camcorders, media players, or mobile phones. While FAT12 is omnipresent on floppy disks, FAT16 and FAT32 are typically found on the larger media FAT was also commonly used on hard disks throughout the DOS and Windows 9X eras, but its use on hard drives has declined since the introduction of Windows XP, which primarily uses the newer NTFS. FAT is still used in hard drives expected to be used by multiple operating systems, such as in shared Windows, Linux and DOS environments. Due to the widespread use of FAT-formatted media, many operating systems provide support for FAT through official or third-party file system handlers. For example, OS/2, Linux, FreeBSD and BIOS provide built-in support for FAT, even though they also support more sophisticated file systems such as ext4 or BTRFS. Mac OS 9 and Mac OS X support FAT file systems on volumes other than the boot disk. Amiga OS supports FAT through the Cross-DOS package. For many purposes, the NTFS file system is superior to FAT in terms of features and reliability. Its main drawbacks are its complexity and the size overhead for small volumes, as well as the very limited support by anything other than the NT-based versions of Windows. Since the exact specification is a trade secret of Microsoft, the availability of NTFS 3G since mid-2006 has led to much improved NTFS support in Unix-like operating systems, considerably alleviating this concern. It is still not possible to use NTFS in DOS-like operating systems without third-party drivers, which in turn makes it difficult to use a DOS floppy for recovery purposes. Microsoft provided a recovery console to work around this issue, but for security reasons it severely limited what could be done through the recovery console by default. The movement of recovery utilities to boot CDs based on BART-PE, Linux, or WinP is eroding this drawback, but the NTFS's complexity forbids its implementation in lightweight operating systems or most embedded systems. The DCF file system adopted by almost all digital cameras since 1998 defines a logical file system with 8.3 file names and makes the use of either FAT12, FAT16, FAT32 or exFAT mandatory for its physical layer in order to maximize platform interoperability. FAT is also used internally for the EFI system partition in the boot stage of EFI-compliant computers. For floppy disks, FAT has been standardized as ECMA 107 and ISO IEC 9293-1994. These standards cover FAT12 and FAT16 with only short 8.3 file name support. Long file names with VFAT are partially patented. Nomenclature. Technically, the term FAT file system refers to all three major variants of the file system: FAT12, FAT16 and FAT32, and most parties clearly distinguish between them where necessary. In contrast to this, Microsoft typically no longer distinguishes between all three of them since the introduction of FAT32, and refers to both FAT12 and FAT16 as FAT, whereas FAT32 gets treated specially in dialog boxes and documentation. This can sometimes lead to confusion if the actual type of the file system used is not mentioned or cannot be explicitly specified. Another common cause of confusion exists within the group of FAT16 file systems, since the term FAT16 refers to both either the whole group of FAT file systems with 16-bit wide cluster entries, or specifically only the original implementation of it with 16-bit sector entries. When it becomes necessary to differentiate between the original and the later implementation, while technically the newer variant with 32-bit sector entries is called FAT16B, it is commonly referred to under the name of FAT16 as well. In particular, since the original variant is rarely seen today and typically only used on small media when backward compatibility with DOS before 3.31 is required. Further, the term VFAT has led to various misconceptions as well, as it is sometimes erroneously used as if it would describe another variant of FAT file system to be distinguished from the FAT12, FAT16 and FAT32 file systems, while in reality it does not specify another file system, but an optional extension, which can work on top of any FAT file system, FAT12, FAT16 or FAT32. Volumes utilizing VFAT long file names can be read also by operating systems not supporting the VFAT extension, for as long as they support the underlying file system. Yet another cause for misconceptions stems from some apparent redundancy and possible ambiguity in the definition of FAT volumes. The general type of file system is determined by the width of the cluster entries in the FAT. Specific threshold values for the amount of clusters have been defined to determine which FAT type is used, even though other properties such as the size of the volume, the count of sectors, the BPB format, the file system name in an eBPB, or in case of partitioned media the used partition ID may often seem to be well-suited distinguishing criteria as well. They cannot reliably be used to derive the file system type from in all scenarios. Whilst uncommon, it is technically possible to define a FAT12 or FAT16 volume using a FAT32 eBPB, which is normally used for FAT32 volumes only. Also, while partition IDs sometimes indicate special properties such as hidden, secure, CHS or LBA access to an operating system, and as such are often used in conjunction with particular file system variants only, they are typically not used to specify a type of file system by themselves, but rather to keep operating systems not aware of a partition ID from accessing partitions they cannot handle or should not work with. It is therefore necessary to distinguish generic FAT file system types such as FAT12, FAT16 or FAT32 from FAT partition types such as FAT12, FAT16, FAT16B, FAT16X, FAT32, FAT32X, etc.